As you recalled in our last videos, we talked about some of the main things that we're going to talk about in biochemistry: carbohydrates, lipids, proteins, and nucleic acids. This video is going to be on nucleic acids. Lipids. Lipids are molecules that are hydrophobic. And if you remember back, hydro means water, phobic means fear of, so they don't like water. So these guys are going to stick away from water, and some fats will have an area that likes water and hates water. We'll talk about them in a second. But the lipids function is for a couple of things. Long-term energy storage makes sense. We use this for storing energy away. Anytime we need it, we access these fats and then burn them to keep us going and give us energy. Hormones, there's a specific subset of hormones called steroids. They're made of lipids. Hormones typically travel through the bloodstream, so these guys have to be coated in something so we can deliver it from one point to another. If it wasn't coated in something, they would kind of get clogged in your bloodstream and have some issues. Lipids also give us structural functionality to the cell. It kind of gives us this wall around the cell, so some things can come in and some things can come out, and it gives us that wall. We'll talk about that soon. And of course, insulation, protective cushioning. Insulation, when the winter is coming, you'll notice that with cats, dogs, and even humans, we get a little heavier, and it's because we store that for insulation. Also, we store it because when you get cold, you start to shiver. And what you're doing when you're shivering is first you start to burn a whole bunch of carbs. And if all the carbs are gone, you take fat, you start burning them, and that shivering is designed to keep you warm. Protective cushioning, you know that we have a little bit of fat around, like, let's say, our pelvis. And that's designed because our pelvic bones are so brittle that if we didn't have fat around them and a lot of muscle around them, the hip could come out. We could actually break parts of our bones there. So by having this fat cushion to sit on, it basically protects our hips and things like that. Lipids are for storage and function. Basically, there's a whole bunch of different types. These all fall into the thing of lipids. Fats, they're long-term energy storage. We talked about them. Oils, they're long-term energy storage. They're usually from plants. They could be from animals as well. Phospholipids, we're going to talk about them specifically, but they have an area that hates water, an area that likes water, and you're going to see a little of that in our next couple of slides. Steroids, we'll talk more about them in Bio 202, or Bio number 2. That's going to be Anatomy number 2. We're going to talk about the specific hormones that are specifically called steroids and what they do for you. Steroids are something your body makes constantly, and they keep you going. Too much of it, of course, is what you see with the bodybuilders and things like that. Waxes are designed to keep water out, even keep some dirt out. So we have wax in our ears, and then of course you know about candles and things like that. Fats have a big long chain that is polar heads, and they have a non-polar tail. Remember back, things that are polar are going to like water. Things that are non-polar hate water. So they don't mix with water at all. And what you're seeing here is that the glycerol molecule right over here likes water. These guys over here, which is the fat, they hate water. They come together to become this thing called a triglyceride. The only way we can add these guys together is by taking the H and the OH and taking them away, so making that water go away, and that becomes the reaction that we're going to remove. Is that going to be called a hydrolysis reaction, or is that going to be called a reaction that we're going to be putting things together? Dehydration reaction. And it's dehydration. And keep in mind, OH over here is just a hydrogen and an oxygen. Here it's a hydrogen. You take these two out, then they become the water. And that's why this became so much bigger. An area that loves water, areas that hate water. Typically, when we talk about lipids, it's usually just this, areas that hate water. But this one's going to be really special. This one is going to be something that we're going to have on the outside of the cells. But before we even go to that, let's talk about the different types of fat, because you've heard about these and you might not know what's going on at the structural level. So you'll notice that this is a fat. It's got carbon, hydrogen on the outside. It's called a saturated fat. And if you recall from hearing a nutritionist or dietitian or somebody on TV, Dr. Oz, they'll say that saturated fat is the bad fat. It's called saturated because everywhere you look, there's a hydrogen bond. So it's completely saturated with hydrogen. So think about things that are saturated. So like, if you hear the word commonly in the English language, you might hear that, oh, you went out in the rain and now your hair and clothes are completely saturated with water, meaning full of water. Well, that's what's happening here, except here, instead of being full of water, it's full of hydrogen. These guys stay straight. There's no kink in them like you see down here, and they start to pile up on each other. These are really bad because in the body they start to form clogs and things like that. Unsaturated fat, and you see that this is the one that we're talking about. This is the good fat. See how it's got this little kink in it? So it's unsaturated because look how a hydrogen could have been bonded here and here. There's a couple that could have still added to this, but we're missing them, and that's why we have a double bond here and a kink. This is the most important part, this bend, that kink. What happens is these unsaturated fats can't pile up on each other. And when they can't pile up on each other, they can't really pile up in your arteries and veins. And that way, they're really good. Where these guys, they can line up like soldiers and sort of create clogs and things like that. And that's what they're typically talking about when they're talking about the hardening of the arteries and veins. Some of it's from bacteria, but a lot of it's from dietary fat. It's the bad fat, the one you're seeing right at the top. So the kinkier the fat, this little bend, the better it is. So some fats you probably hear are awesome, and it's just because they have tons of these bends. And the more bends they have, the less likely they are to stick in your arteries and veins. And when you start to make the outside component of your cells, they're made of these good fats. So that means stuff can go into the cells really easily and stuff can go out of the cells really easily. If your cells are made of this mostly saturated fats, it becomes kind of stiff. And gases can't leave really easily, so like CO2 and oxygen can't come in as easy, and then waste products stay in the cell longer, which is bad, so this becomes a major problem. So the better diets usually have higher amounts of unsaturated fats, olive oils, walnut oils, things like that. You probably don't buy a lot of them because they get kind of rancid, and rancid is that weird smell it has. It even has a funky taste. And the reason why it goes rancid is, see this little spot over here? Oxygen binds to it. And that's what gives it that rancid smell and that taste. And that's why they usually say something like the best oils are going to be like sunflower and walnut oil. They're awesome. But you can't buy a ton of it because it goes sort of rancid really quickly. So they sell them in small bottles because if you bought a big tub of it, more likely after a couple weeks it's going to go rancid and bad. Where this guy, saturated fats, there's nowhere for oxygen to bond. So they stay pretty stable. So butter, you could leave butter on the countertop for 10 years and it's going to taste as good as it did on the first day to the 10th day. It might have some weird hair and stuff on it. Ooh. But the rest of it's going to be okay. Way back in the day, when people used to make bacon, what they would do is take that fat and sort of save it in a can. And anytime they needed any of that fat for like making eggs or something, they'd just take a scoop of it and use it. And that fat can would sit out for years and basically it would never go rancid. Try doing that with one of these fats. That's not going to work. If we look at the fats that are kind of in your body, that are in your body, you'll notice that there's an area called a glycerol. This area likes water. Remember we talked about this just earlier? And then there's an area that hates water, this fatty acid area. And you'll notice, one of them has a kink and one of them doesn't. So these kinkier ones, the double bond makes it kinky, those are the good kind. So what happens is we can take thousands of these and start to line the outside of a cell, like you're seeing here. So this is the area that loves water. Another way of saying that is called hydrophilic. These are the areas that hate water. These are the hydrophobic. And you'll see that one of those lipids have lined up with another one, and they've automatically come together where the area that hate water are on the inside, the areas that love water on the outside, and one side of the cell is facing the outer part, and one side is the inside of the cell. So what you've done is create an area that loves water, a thin layer that hates water, and then the area that loves water. So what this ends up being is almost like a gated community where some things can come in, but large structures can't, and we're going to have to build special things to let those in. We'll talk about that soon. Anything that has the ability to have some area that loves water and hates water is going to be called ambipathic. So ambipathic means that it has polar and non-polar regions. So again, we said that a type of fat, we make hormone, and one is called a steroid. We have them different types. One of them is one we call cholesterol, and the cholesterol, we use it for a few things. It helps the phospholipid bilayer by basically making it a little more bendable and movable. So these are going to be those good cholesterols they talk about. And of course, there's some hormones that we'll talk about soon, and they have these fatty products as well. So what you could see here is the lipid bilayer and a cholesterol in the middle. And the cholesterol basically makes it so the outer cell moves around quite a bit and is more flexible. We'll talk why that needs to happen in our next unit. You've heard of steroids. They're definitely the hormone that people think about when they're thinking about these fattier ones. And they help build up muscle. And we make a little bit on our own, but too much of it is not natural. It's harmful to our health for both males and females when you make way too much of it, and it basically destroys anything that makes testosterone or estrogen in males or females. And like in males, it'll basically go ahead and start to shrink and reduce the size of the testes. That's where testosterone is made. And then in females, they'll actually start to make an effect on the ovaries and some of the other female glands, because again, this other thing is replacing it, so they don't think they have to make it anymore, so they actually kind of go into remission. So too much of it is really bad, but too much of anything is really bad. Our next unit is going to be on proteins.